Okay, so we in the world of kind of miscellaneous questions here and geometric sequences and series. Here we got the sigma, so already we're thinking sums and series. And we've got two different sums going on. The first one clearly has an infinity sign, so we're thinking of some sort of sum to infinity. And the second one, well, there's a value of n that we don't know that we're trying to find, but with 2t minus 3, should hopefully be able to see that that's an arithmetic progression going on, increasing by 2 each time. But let's just kind of break that down and get into the question. So this first part here, well, let's substitute different values of k. If k is 1, we've got a half, plus if k is 2, we've got a half squared, which is a quarter, plus, and that's going to carry on forever. Now, this sum, I'm just going to stick to this because I already recognize this is a sum to infinity of a geometric progression. So we've got a geometric progression where our first term is a half and our common ratio is also a half. So our sum to infinity is a over 1 minus a half. So that's what this first series over here is doing. Well, if we work that out, punch in the calculator or work it out, we know that that's 1. Now, I just ran with that rather than moving on to the next one because that's what I felt comfortable with and I just wanted to keep that roll going. So I already know that that's 1 plus something else. This here is a series. Let's sub in values of t to c. 2t minus 3 where t is 1. 2 times 1 minus 3. 2 minus 3 is minus 1. Plus, you might see that the common difference is 2 from the formula given, or substitute 2 in. 2 times 2 is 4, 4 minus 3 is 1. And so this is going to carry on, but we don't know what the last term is, and we don't know how many terms there are. So that I'm just going to put like that so far and say equals 196. Now this is an arithmetic progression. Our first term's minus 1. Our common difference is 2. And we don't know really much else about it. It's a sum, but we don't know what the sum is, and we don't know what n is. So let's leave that as it is and say that whole thing we don't really know much about yet equals 196. But it's a sum of some kind. So we know how to work out the sum of an arithmetic progression. It's n over 2, right? And n over 2, 2a plus n minus 1d. Okay, well it feels like we're getting somewhere because if you start looking at your equation, you can see there's only one thing we don't know, and that is what n is. So I'm going to simplify this in the next step because I don't know, I just like to simplify as I go so we don't keep rewriting too much. Well, 2 times minus 1 is minus 2. And I'm going to distribute the 2 into the brackets plus 2n minus 2 equals 196. Okay, subtract 1 from both sides. N over 2 minus 2 is minus 4. So already we're just sneaking things to be a little bit simpler as we go. And we can see a quadratic coming out as we go along here. So we just need to solve our quadratic. Generally what we did was we said, well, this fraction thing isn't so great. We're going to multiply both sides by 2. Or you might see that if we take out a 2 here, those are going to cancel anyway. So n squared minus 2n minus 195 equals 0. But it's a quadratic, so solve it however you're comfortable with. And of course, you know your factors are 195. So let's see, it probably just factorizes nicely. 13 and 15. Now, in all seriousness, I can see that this is minus 2. So if I take the square root of 195, if I don't want to just reach for the quadratic formula, I get 13,96. Now, because this is 2, I expect the factors to be kind of close together enough. So I'm going to kind of guess at 13 and 15, but maybe the quadratic formula was just quicker for you. So we've got plus 13 minus 15. So n is certainly not negative 13, but n is 15. Okay, n can't be negative or a fraction, a non-positive integer. So there we go. There's how we solved that one. Oh, wasn't that fun? I'll see you in the next one.